So question 1 says that if a particle moves from a certain point with a constant velocity of 25 meters per second towards another point, then we have to find the velocity vector. So this is a bit about application of vectors in kinematics, that type of question it is. It says that, if you have a particle that is initially, let's say, at this point A, which is 0, 1, 2. The coordinates are 0, 1, 2. And now it is moving towards another point B. जिसके coordinates are 3, 5, 2. So as it is moving from this point to this point, its displacement vector will be the vector joining the initial point with the final point. So the displacement vector should be the vector EB. Okay. So what we can write the displacement vector, but before that, also is moving with uniform velocity. So uniform velocity का मतलब क्या होगा? The direction of velocity will be along displacement. Because the displacement should be velocity into time. So since it's moving at uniform velocity, therefore the displacement should be equal to velocity multiplied by time. So that means displacement and velocity are along the same line, or in vector language we'll say that they have same unit vector. In other words, the unit vector of velocity should be equal to the unit vector of displacement. This is the first thing we understand. Now the next thing is, what is the displacement? Okay, so the displacement itself, you can see, is nothing but this line AB, A to B. So it will be from 0 to 3, so that is 3 I cap, plus 1 to 5, so that is 4 J cap, plus 2 to 2, so that is 0 K cap. So the displacement vector is this. So that's the second thing that we do. So from this we can see that the displacement's unit vector is nothing but the displacement vector divided by its own magnitude. So that is 3 I cap plus 4 J cap divided by its own magnitude, which is 5. So it is 3I plus 4J divided by 5. This becomes my unit vector along the displacement. So now from equation 1 and 2, I know that velocity's unit vector is the same thing as displacement's unit vector. So velocity's unit vector is how much? 1 by 5, 3 I cap plus 4 J cap. And velocity's magnitude, दिया हुआ है मुझे क्वेश्चन में 25 meters per second. So velocity vector कितना होना चाहिए? It should become the magnitude, which is 25 meters per second, multiplied by the unit vector, which is this. So the velocity should become 5 into 3 I cap plus 4 J cap in meters per second, or you can also write it as 15 I cap plus 20 J cap in meters per second. This becomes my velocity. Okay, so hope this question is clear. So here we are making use of the concept that, two important concepts, that any vector can be written as its magnitude multiplied by its own unit vector. So over here we have made use of the fact that velocity vector is its magnitude multiplied by its unit vector. This is coming from the fact that the unit vector is defined as a vector divided by its own magnitude. So इसका reverse किया जाता है. This is one thing we are making use of. And the other is that parallel vectors have same unit vector. So P and D are parallel vectors or they are along the same line. Another way of expressing it. So A cap will be equal to B cap for A being along or parallel to. So that is that question. So just make a quick note of this. If you had a doubt in this, and let's come to the third question. ये बेटा यहीं से है ना. Any vector can be written as magnitude into its unit vector. So velocity vector can be written as the magnitude of velocity multiplied by the unit vector. Where this comes from? This comes from the definition of unit vector. Okay, Rudra, just hang on a second. I will finish the module, the assignment 7 doubts first. Then I will come to the module. Just let me complete these doubts, Rudra. Then I will come back to the module doubts. Vaishnavi, I've got your message about question number 7. I will come to that. Let me finish question 3 and 4 first. So let us come to question 3 next. So question 3 is actually related to the data of question 2, in which it is given to us that the vector B is 20 j cap, right? And the vector E is 2 I cap plus root 3 j cap. 2 I cap plus 2 root 3 j cap. Now in question third part, we have to find the component of B perpendicular to A in magnitude. So we have to find B's perpendicular components magnitude. The component or projection of B perpendicular to E. So this question can be done in a number of ways. The first method, the easiest method I'll tell you, is that the parallel component of B is equal to B cos theta into A cap. If I or its magnitude is just B cos theta. So if this is the vector B and this is the vector E and this angle is theta, then you drop this perpendicular. So ये वाला component B का parallel component हो गया और ये वाला component, the one at 90 degrees to this, that is the perpendicular component, like that. So that thing. So one way is that we can calculate this by A dot B divided by mod E. So work out A dot B from here. You can see it is 40 root 3 and mod A you can see is 4. That is 10 root 3. So you can see that B perpendicular is this. Okay, now we can use the relation that B parallel plus B perpendicular is equal to the vector B. So magnitude wise what is happening, since these two are perpendicular to each other, so B's magnitude should be equal to square root of B parallel square plus B perpendicular square. So we can make use of that. So or in other words, B perpendicular's magnitude will become B's magnitude square minus B parallel's magnitude square. So from here you can see that B's magnitude is 20 And from here you can see that B parallel magnitude is 10. Just substitute these. So B perpendicular here will become 20 square minus 10 root 3 का whole square. You can see that that will become 10. नहीं यहाँ पे जरूरत नहीं ना, यहाँ पे सिर्फ मैग्नीट्यूड पूछा बेटा, तो ए कैप नहीं यूज कर रहे हैं. Here I have not asked for. See, the question has not asked for the vector form, so I am not using this. This is not asked for, so I am not making use of that. But suppose मैंने पूछा होता that okay, what is B parallel vector in this? Then I would have said that okay, it is B cos theta into E cap. So I would have calculated E cap, that is vector E divided by mod A. So that in this case would have become I cap by 2 plus root 3 by 2 j cap. Calculate. I would have substituted that over here. I would have got that okay. Parallel component is this 10 root 3 into that unit vector. So my answer would be this. This would have become B's parallel component, and then B's perpendicular component would have come by doing the vector subtraction. From here it would have come B perpendicular is equal to B vector minus B parallel. So this vector minus, okay. But here that is not asked. What is asked? The magnitude. So I can just do this. Understood, Rudra? Okay, good. So that's one way. The other way we could find B perpendicular is like I'm proceeding here. From this I could find B perpendicular as a vector as B minus B parallel. So that is 20 j cap minus this. So you will see that that becomes minus 5 to 3 I cap plus 5 j cap. That is B perpendicular. So its magnitude is becoming square root of 5 to 3 square plus 5 square. That's 10. So that's another way of finding it. Or yet another way, see, in this case, these are two-dimensional in the xy plane. So these vectors are quite easy to draw. Actually. So you can, in this particular case, you can also find by geometry. Alternately, we can also find this by geometry. So in the geometrical method, what you do is you draw your two vectors, A and B. Because they're in the xy plane, you can easily understand them. You see that your vector E was given as 2 I cap plus 2 root 3 j cap. So this is a vector of magnitude 4 at 60 degrees to x-axis in the xy plane. So this as a vector will look something like this. This angle is the important one. Along the direction, it is making 60 degrees to the x-axis. Likewise, your vector B is much easier to draw in fact. Okay. Vector B is given to us as 20 j cap. So you don't have to think much about it. See the vector B's diagram में ऐसा कहीं है. Its magnitude is 20. So we have to understand that this is the parallel component, and similarly this angle will be 90. this perpendicular and this perpendicular. So this is the parallel component and this is the perpendicular component. There's another way we can do this because we know that magnitude of the vector B is 20 and we also now know this angle. This angle is 30 degrees. We can see that B perpendicular will just become B sine theta. Okay, so that is nothing but 20 into sine 30 degrees. That is 10. Similarly, B parallel, B cos theta is 20 into 3 by 2 is 10. So because they are two-dimensional vectors, you have this method also. Okay. This method is also available. But in general, for 3D vectors, we can't draw them like this. So we prefer the method using the dot product to find the projection. We prefer this projection method. This is applicable for both 2D and 3D vectors. Whereas geometrically, it's only possible when it's 2D vectors. So just go through this once more and we will come to question 4 next. This one, yeah, no, this is like geometrical. No? The angle between A and B is theta. So this angle is theta, and this is a magnitude B. Then this and this is the definition. No? The component of B parallel to this along this line will be B cos theta, and the component perpendicular will be B sin theta. वो तो definition हो गया ना components का. Understood, Shikhar? Okay, so that was question number 3. Now let's come to question 4. Number of people have asked question 4. It says that you have a unit vector in the xy plane. N cap is a unit vector. Cap always is used for unit vector only, but in this case it's specific. It's in the xy plane. Okay. So therefore, we can say that n cap must be having some x component, let's say xi cap, plus some y component yj cap, such that square root plus of x square plus y square should be unit, or in other words, x square plus y square should be equal to unit. That's our first equation. Okay. Secondly, given to us that n cap dot I cap is equal to 0.6. In other words, x I cap plus y j cap, this vector's dot product with I cap is 0.6. Now solve the dot product on the left hand side. It's nothing but x. So x is 0.6. That's the second information that we are getting from this thing that this is giving us this. So now just substitute that in the first equation. Therefore, 0.6 whole square plus y square is 1. So this will give you that y is plus minus 0.8. So that means the unit vector n cap is 0.6 I cap. It can be plus 0.8 j cap, or it could also be ये भी हो सकता है. So there are two such unit vectors which have the property that they lie in the xy plane, but at the same time their dot product with I cap is 0.6. Okay, so this is and I've been solving questions, so you can just pick up these questions later from the recording if you got this thing on. Okay, so after question 4, the next thing we'll be solving is question 5, then question 7, then 11. Okay, so let's come to question 5 next. Let's complete going through this, then we come to question 5. Okay, so question 5 says, actually it should be mod. You can see that vectors are not equal. It's mod A is equal to mod B is equal to mod of A plus B by root 3 is equal to 10. You should solve it this way. Then A dot B is how much? To find out how much A dot B. So here we make use of this, that mod of A plus B by root 3 is equal to 10. So this means that magnitude of A plus B is 10 root, and magnitude of A is 10, magnitude of B is 10. So use triangle law. So root of A square plus B square plus 2AB cos theta, where theta is the angle between A and B, is 10 root. So solving this, you will get cos theta equal to half, or theta equal to 60 degrees. So therefore, your A dot B being EB cos theta becomes 10 into 10 into cos 60, which is 50. So this is also fairly straightforward question. So just complete this, then we'll come to question number 7. Number of people have asked question 7, so let's look at it carefully. Okay, the place will come to ninth question also. Let's finish seventh first. So 7 says that we have to find the area of the triangle formed by these two vectors. So it's like this, that if you have two vectors A and B, which are at an angle theta, and we want to find out this area, the area of the triangle. So area of triangle become half into base into height. Now you can see here that the height of this triangle height is nothing but b sine theta, and this base is nothing but the magnitude of it. So you can see that it is half of b sine theta. So it is nothing but half of magnitude of a cross b. In fact, you can see whether you're talking about this triangle or you could be talking about the sum of vectors triangle, even that is the same thing. So if you have a triangle formed like this, so the angle between them, so that also has the same area. Both these triangles have the same area. Because here also you can see the height of this triangle is the same. This is the height and this is the base. So while they are different triangles, but they'll have same area. So here all we have to do is find this cross product. E was given to us as I plus j plus k, and B was given to us as 3i cap. So E cross B is I plus j plus k cross product with 3i cap. You can see that that is 3. J cross I is minus k plus 3 into k cross I is j. So it is 3j cap minus 3k cap. So that is our E cross B in component. So now the magnitude of A cross B is the root of 3 square plus 3 square. That is 3 root 2. So the area of the triangle will become half of 3 root 2. So it is 3 by root 2. Arey Shikhar, that's not a question worth asking. कोई भी साइड से ले लो ना बेटा, कोई भी ट्रायंगल ऐसा ABC ले लो. अभी whether you take this into this side, okay, you take this as base and this as height, or you take this one as the base and this one as the height. The formula is the same now. Yeah. So if I'm not mistaken, there should be a correction in the answer key in this question. The answer key might be wrong. It should be C option. Okay, just check once. Yeah, make a correction to the answer key. Okay, it's given as B. It should be C. C is the right one here. Okay, so that is this question. So just make sure you remember this. We had discussed in definition of cross product, that magnitude of cross product is area of parallelogram. Area of parallelogram. So that is the same thing as 2 times the area of triangle. If you draw the vector parallelogram, it has an area which is twice the area of the triangle. Twice the area of the triangle. Okay, next let's come to question 9. So question 9, 2 points are given to us and we have to find the displacement vector from one point to another. So this is just like that earlier question we had done. So if this point is A and this point is B, then A to be the displacement vector. It becomes like this. If this is x1, y1, z1, and this is x2, y2, z2, then that displacement vector becomes x2 minus x1 I cap plus y2 minus y1 k cap plus z2 minus z1 k cap. So here just substitute the values. So 4 minus of minus 2, so that will become 6 I cap. Then 5 minus of minus 4, so that will become 9 j cap. And 6 minus 0, so that will become 6. This should be the displacement. Okay, Ananya, I'll come to 12th question. A lot of people have asked for the 11th question solution, so we'll do that. Then we'll come to the 12th question. So just go through this once more, then come to the 11th question. So vector E is given to us as x I cap plus 2 j cap plus 2 k cap. And vector B is given to us as 2i minus 4j plus 1. So we have to find the condition for A and B to be parallel. You know that if A and B are parallel, then A should be equal to some scalar number times B. Or another way of expressing it is that A cap is equal to B cap. But this is the easier one. We'll go with this. So if this is the case, that means that Ax upon Bx should be equal to Ay upon By, should be equal to Az upon Bz, should be equal to that ratio, whatever that is. Okay. So just apply that over here. So in this case, that means that x by 2 should be equal to 2 upon minus 4 should be equal to 2 by y. This condition. So as you can see, x will become minus 1 and y will become minus 4. But just one point over here, actually they will be anti-parallel vectors, because the condition for parallel versus anti-parallel is that here, if n is positive versus if n is negative. So if this ratio is positive, that means they are parallel. And if it is negative, then they are anti-parallel. So for example, if this is the vector E, and suppose we have another vector B, which is 2A, suppose. In that case, this vector B will look like this. It will be twice in magnitude, but along the same line. It will look like this. But on the other hand, suppose we have another vector like C, which is minus 3 by 2A or something like that, some negative number in between, then that particular vector will look like this. It will be anti-parallel. So you can see that. So यहाँ पे क्या हो रहा है ना, this ratio, this n is actually equal to minus half that n is. So therefore, A and B are actually not parallel, but they are anti-parallel. Okay, so that's question 11. Let's come to 12 next. 12 and 15 you have to finish before we come to the exercises again. Yeah, so 12 is an important question. It's related to the coplanarity condition. Okay, Rakshit. Answer of question 5. We discussed now it was 50. Okay. So let's come to question 12 now. This is something very important and also different from this. Okay. Coplanarity condition. We'll come back to question 12, the data and all that. But let's first understand condition for coplanarity of 3 vectors. Let's understand. So suppose vectors A and B are in the plane of this. Suppose A and B are in the plane of this plane. Okay. Then for A, B, and C to be coplanar, okay, C should also be in the same plane. C should also be in the plane of A and B, which in other words is the plane of the screen. So C should also lie within this plane, somewhere here or wherever, it doesn't matter, but it should be in this plane. C should not have C should not have component perpendicular to the plane of plane. That is in my diagram, it is the plane of the screen. That is the meaning of this. Now let us see how we'll find the mathematical condition. That is the meaning of coplanarity of the three vectors. Of vectors A and B. Okay. So therefore, if C is coplanar to A and B, then that implies that A cross B is perpendicular to C. So this is the condition that we use to solve the problem. Okay. So just note down this condition. So coplanarity is this. This here becomes the condition for coplanarity of three vectors. This is how we check if given vectors are coplanar or not. So just apply this concept now to the three given vectors A, B, and C in the question 12. Okay. Just apply this condition that A cross B should be perpendicular to C. Just apply that condition and you will get the answer. Okay, so note this down and try applying this method. We'll discuss. Try applying this method yourself. Okay, so let's apply this method now to the vectors given in question 12. The vectors given are 2 cap, 2 cap plus 3j cap. Minus 2k cap. That's one vector. Then 5 cap plus nj cap plus k cap, and minus I cap plus 2j cap plus 3. Okay. So we have to find n so that they are coplanar. Find n such that the 3 vectors are coplanar. So we can take E as this vector, 2 cap plus 3j cap minus 2k cap, and instead of taking B as this one because it is an unknown quantity, let's take B as this one, okay, the third one. So B becomes minus I plus 2j plus 3k, and C becomes this vector, 5 cap plus nj cap plus k cap, where n is the unknown quantity. So if E, B, and C are coplanar, then C should be perpendicular to A cross B. Perpendicular condition क्या होता है? Dot product should be 0. So C's dot product with A cross B should be 0. So from that we will get n. Okay. Yeah. So let's work this out. So the first thing here is now I have to find the cross product. Okay. So let's first of all find out how much is the cross product. So E cross B will be this matrix. E's components are 2, 3, minus 2. B's components are minus 1, 2, 3. So this determinant will become this. Okay, let's check these values, they should be correct. So this will become 9 minus of minus 4. So that is 9 plus 4. So 13 I cap. Okay. This will become 6 minus of 2. So that's 4, but with the minus sign outside. So minus 4 j cap. And this will become 4 minus 3. Sorry, minus of minus 3. So that will become 7 j cap. So this is A cross B. Therefore, C is perpendicular to A cross B. Means that C's dot product with A cross B should be 0. So that means that this vector 5 I cap plus the unknown quantity nj cap plus k cap. This one's dot product with this new vector that we got 13 I cap minus 4j cap plus 7k cap would be 0. Further, this means that 65 minus 4n plus 7 should be equal to 0. 4n should be equal to 65 plus 7, that is 72. So n should be equal to 18. That should be. So this is an important concept, okay, and an important type of question related to that concept. So condition of coplanarity. Okay, just go through this one more time, and then again understand how we applied it in this below. Yes, Shikhar, the answer is 18. That's correct. Finally, after this, let's wind up with question 15. Okay, Shikhar. So we found out A cross B. Then we found out the condition for C to be perpendicular to A cross B by taking the dot product as 0. Okay, so that's that. That's this question. Let's come to the 15th question as the final one. So I think that's the only one pending now. Yeah, nobody has asked 13th or 14th, so I'm assuming that is done. Okay, so next go through the 15th question. I'll explain it to you. So question 15 में E and B are two unit vectors which are non-collinear. Question 15. First of all, it is given that E1 and E2 are non-collinear unit vectors. So unit vectors means that their magnitudes are both unity. Both of them have a magnitude of 1. This is something that we know. And Also, it is given that magnitude of A1 plus A2 is root 3. So this means that root of A1 square plus A2 square plus 2A1 A2 cos theta is root 3. So substitute again the magnitudes of A1 and A2. So 1 plus 1 plus 2 cos theta is root 3. So again we will get that cos theta is equal to half, or theta is equal to 60 degrees. So this is the second equation that we are getting from the second condition which is given, which is this one. The first is that they are unit vectors, so this. Second is that if magnitude of A1 plus A2, now we have to find this thing, which is A1 minus A2 dot product with 2A1 plus A2. So we have to find A1 minus A2 dot product with 2A1 plus A2. So what we do first is we open this bracket. Okay, this will become 2A1 dot A1 plus A1 dot A2 minus 2 times A2 dot A1 minus A2 dot A2. So this opening of the bracket by this method, this is called the distributive property. We're making use of distributive property in algebra. Now, the other thing you know is that any vectors dot product with itself is nothing but its magnitude square, which is 1. Similarly, A2 dot A2 is A2 square, which is 1 because magnitude is 1. And also, you know that A1 dot A2 is the same thing as A2 dot A1, which is the commutative property of dot product. So make use of that over there. So that thing, E1 minus E2 dot product with 2E1 plus E2. E1 square, okay. E1 square, I mean E1 dot A2. Okay. Minus E2 square. So E1 square is 1. This will become cos theta minus 1. So this will become minus cos theta, which is nothing but minus 1. That should be a final answer. Oh, sorry, this is 2E1 square, my mistake. So this will be different answer. So 2 minus, that is 1 minus cos theta was half. So this should be half. This should be your final answer. So this is just a bit of manipulation and algebra. Nothing very conceptual about this. Okay, people, so this completes the worksheet 7 discussion. Now, please let me know what doubts you have pending from the module exercises. So you can finish that off and finish off vectors with that then. So any doubts pending from the module, please let me know. Okay, Durgesh. Exercise 4, question 3. Okay. Anything before exercise 4, exercise 1 and 2, anybody has a doubt, please let me know. So let's go in order. Anything from exercise 1 pending? Does anybody have any doubt from exercise 1 of module? (19) and 6. Okay. So let me complete exercise 1's doubts, then we'll come to exercise 2 and 3 and 4. Okay. So module exercise doubts. Okay, hang on. So exercise 1, I'm having question 19, 6, 8, 10, 13, question 16. Okay. Yeah, Rudra, I'll come to exercise 4. Okay, just let me complete exercise 1 and 2 first. Okay. So let's start with question 6 then. Yeah, question 6 is like this, that you have 3 vectors of magnitude 1, 2 and 3. So let's say magnitude of vector A is 1, magnitude of vector B is 2, and magnitude of vector C is 3. Okay. And the vectors A, B and C are along the consecutive sides of an equilateral triangle. Okay. So we have to find this. So first of all, let's try to understand the meaning of this statement. Okay. Consecutive or taken in order, the sides which are taken in order. Let's try to understand what this statement means. Okay. So this statement basically means something like this, that imagine you have an equilateral triangle like this. So these angles are 60. That's the same thing as saying that the exterior angles are all 120. So let's say this triangle has vertices P, Q and R. So now the above statement is saying that A, B and C are along the sides of triangle PQR, taken in order. So taken in order का मतलब क्या है? That suppose E is along PQ. Okay. So then B should be along QR. C should be along RS. Okay. And plus it is given to us that magnitude of A is 1, magnitude of B is 2, magnitude of C is 3. Okay. So now I don't know what the side length of the triangle is. It could be anything. So let me assume it's a large triangle. Okay. So then A should be a vector which is, let's say, like this along this side PQ, but of magnitude unity. So then in comparison, how is the vector B going to be? B is going to be a vector like this along the side QR, but of magnitude 2, double of A. And correspondingly, C will be a vector which will be of this type now. It's of magnitude 3. Okay. And we have to find A plus B plus C. So the easiest way to deal with this now is next we convert ABC to component form. So next what we'll do is express A, B and C in component form, where we just take our xy axis, suppose like this. We take our xy system such that our x-axis is parallel to the base of the above triangle. So that means our vector E should become along the x-axis. So if we take the system like this, then our vector E would have become like this. It's a vector of magnitude 1 along the x-axis. Yeah, so E is just I cap. So the vector E in component form we just write as I cap. But in comparison, how is the vector B looking? It will be at 120 degrees like this. B will be of magnitude 2 units, but this angle will be 120. So B will become what? 2 into cos 120, so that is minus 1 I cap, plus 2 into sin 120, so that is root 3 j cap. And in comparison, how is this vector C looking now in this? The vector C will be something like this. It will be at 122B. It will be along this kind of direction. But its magnitude will be longer. So the magnitude of this is 3 units. Okay. And this angle is 120. So you can see that C's x component will become C cos 240. So that is 3 into minus cos 60. So that is minus 3 by 2. And C's y component will be C sin 240. Because the angle with the x-axis you can see 120 plus 120. So that is 3 into minus sin 60. So that is minus 3 to 3 by 2. So in component form, the vector C will become minus 3 by 2 I cap minus 3 root 3 by 2. Now it is very easy to find the resultant of A plus B plus C. It's very easy to find that, and it's very easy to find the magnitude of the resultant and all that. So you can just do the vector, the component vector analysis now. The main thing is understanding the language of the question, and from that converting the vectors A, B, and C to component form. So that is why you need to pay attention to this, how this statement has been converted into this. Okay, Shikhar, I will note down these also. Okay, but first just make sure you are clear about this question. You still have to complete the solution. You have to add these and find out. But now from this step, it's easy. Okay, good. Okay, so next move. Let's move on. So we have we also have question 10. So that's already there. 11, 17, and 19 is already there. Okay. So 6 is done. Next, let us move on to 8. So question 8 from exercise 1. Okay. So question 8 में क्या करना है? We have to find the work done. So you have to just understand that the definition of work done is dot product of force and displacement. So force is already given to us in the question. Force in question 8 is given to us as minus 2 I cap plus 15 j cap plus 6 k cap in newtons, and displacement is given to us to be body is constrained to move along the y-axis and it moves by a distance of 10 meters, so it will become 10 j cap in meters. So work done will become dot product, which you can now see dot product of these two will become 150 Newton meters, okay, or that is 150 joules. So this is a definition we will see in a lot of detail later in a chapter called work power energy. But for now, you can just note down this one formula, that work done is defined as dot product of force and displacement. Okay, so that's the 8th question done. Now next, let's move on to 10th. So we have to do 10th, 11th, and 13th, and 16th, and 17th, then 19th. These are the questions we have to do. Note of these. Right, so let's move on with it. Question number 10. It says a vector A points vertically downwards and B points towards the east. Then what is the cross product of A cross B? Okay, so this is very simple. What we can do here is, suppose we define our XY plane as north, south, east, west. Okay. Suppose our x-axis is pointing towards east. So our negative x-axis will be pointing towards west and our y-axis will be pointing towards north and negative y-axis is pointing towards south. Okay. So here also understand that in this case, z-axis, the positive z-axis is coming out of the plane. Okay. And that will represent which direction? That will represent the vertical up direction. Okay. So plus k cap will be the vertical direction. And accordingly minus k cap will be vertically downwards direction. This is vertically upwards. Or if you want to understand this three-dimensionally, that also we can do. So you can see that if you draw an imaginary two-dimensional plane like this. Now suppose this is our horizontal plane. This is, suppose, a horizontal plane, like the floor on which you are standing. So in this, my XY system is like this. This is my Y-axis, which is pointing northwards, and this is my X-axis, which is pointing eastwards. Now here, how will the vertical axis look? The vertical axis will be this one. So this will be my Z-axis, which is vertically upwards. So Z-axis is, these axes are mutually perpendicular, as you can see. That kind of thing. Okay. So now what it's saying is that the vector A points vertically downwards. So A is vertically downwards. That means A is like this, because minus K cap is vertically downwards. So A should be vertically downwards, means it's along minus K cap. And similarly B is towards east. So vector B is towards east. That means it is along I cap. So B should be equal to some magnitude into I cap. So now you can use your right hand palm rule, okay, or you can use this. So we want to find A cross B. So you can use your right hand palm rule also, or you can directly use the unit vector notation. Okay. So A cross B ऐसे निकालेंगे, the direction. So one is, you can see from here that it is along now K cross I. You remember this, we have easily seen. So K cap cross I cap is J cap with the plus sign. So this becomes minus AB J cap. So it is along minus J cap or south. Okay. So A cross B finally becomes southwards. That's one way. The other way is you can use your right hand thumb rule. So to calculate A cross B, in this diagram you can see A is like this, it's pointing into the plane, and B is like this, is pointing eastwards. So A cross B will point along this direction. So if you point your thumb downwards and your right hand fingers like this, this is vertically downwards, and your fingers are eastwards. So you see your palm will be facing in the direction of south. So that is the direction of A cross B. Okay, people, so hope you are clear about this. That was the 10th question. So just make a note of this if required. Okay, moving on. is done, next let's come to 11th question. It says a particle has a velocity towards the east of 5 meters per second. So my initial velocity is 5 meters per second towards east. Okay. And after 10 seconds, the final velocity becomes 5 meters per second towards north. Okay. And during this change, the time is 10 seconds. So we have to find the average acceleration. Okay. So average acceleration, as you know, in kinematics is average rate of change of velocity with respect to time. So that is nothing but final velocity minus initial velocity divided by the time interval. So for that we have to subtract these two. Okay. So if we just make a geometrical vector diagram in which we take our geographical directions like this. This is north, this is east, west, south. So in this diagram, you can see our initial velocity will be pointing towards east. So that will be a vector like this. Let's say this is a vector of magnitude 5 meters per second pointing towards east. So this is my initial velocity vector. Similarly, my final velocity vector will become which one is pointing northwards, but of same magnitude. So 5 meters per second pointing northwards. This is my final velocity. So now I have to find out delta V, which is the difference of these two. So delta V by triangle law, parallelogram law, whichever one you use, will become this one. This one. V initial or V final minus V initial, like that. This direction. Okay. So this is my delta V or final minus initial. See, remember we use this. If this is the vector A and this is some vector B, both drawn from a common origin, then this is the vector parallelogram. So in this parallelogram, this vector is A minus B. Now from the head of B to A is A minus B. Similarly, if you just draw this vector, pointing from A's head to B's head, this is B minus A. They are equal and opposite of each other. You can see it's nothing but equal and opposite of the vector A minus B. So like that, here this would be the whole parallelogram. It would become a square because this side is equal to this side. So you can see that magnitude of delta V is 5 root 2 meters per second. But what about the angle? This angle is 45 degrees. So delta V is a vector of 5 root 2 meters per second towards which direction? Northwest. Okay. Because you can see that this is your north direction, this is your west direction. So this direction, this is pointing in which direction? Northwest. Or this angle being 45. So coming back to your average acceleration, so that is 5 root 2 meters per second divided by 10 seconds along northwest. Okay. So that becomes 1 by root 2 along northwest. And the unit becomes meters per second square. Because it is. Understood, Shikhar? This thing, ये north direction है, ये east है, so ये west है. So ये वाला direction क्या होगा? The arrow which is pointing in this direction at 45 degrees. This is northwest now. So that is where this delta V arrow is. Okay, so that is the 11th question. Let's move on now. 13th question. So just write this down if you require. Now come to 13th question. Now 13th question is basically just like the question we discussed from the assignment 7. Couple of questions to do with displacement and velocity we had seen. So use that concept. So you can try out this question 13 yourself now. इसमें क्या हो रहा है that it is given to you that at t equal to 0, a particle is, let's say, over here at this point E, suppose, which is given to us as 1, 0, 0. Okay. And now it is moving directly towards another point B at which is at coordinate 4, 4, 12, and it's moving with a velocity which is of magnitude 65 meters per second. So it's moving at uniform velocity v, such that the magnitude of that velocity is okay, and it is along AB. So we want to find now in the question the position at t equal to 2 seconds. So at t equal to 2 seconds, we have to find the position. So suppose a particle going along this line reaches somewhere here at t equal to 2 seconds. So इस point के coordinates निकाल. Okay. So how we will do that? We will see that we have to find C's coordinates. So we can find AC vector as the displacement in 2 seconds. Okay. So that is nothing but the AC vector will be equal to the displacement in 2 seconds. So that will be velocity multiplied by 2 seconds. So the main thing is we have to find out the velocity as a vector. What is the velocity as a vector? So for that you can see is the vector EB is how much? It is 4 minus 1 I cap plus 4 minus 0 j cap plus 12 minus 0 k cap. So that vector is 3 I cap plus 4 j cap plus 12. So now velocity is along AB. So this means that velocity is along, let's say, a unit vector n cap, which is nothing but the vector AB divided by its own magnitude. So that is nothing but 3 I cap plus 4 j cap plus 12 k cap divided by mod of this. Okay, which you can see will work out to be 13, the mod. In the denominator, you will get it as square root of 9 plus 16 plus 144. So you can see that 9 plus 16 plus 144 is 169, which is 13 square. So this will come out to be 3 I cap plus 4 j cap plus 12 k cap divided by 13. So that in this diagram, that is this unit vector. This unit vector along EB, that is n cap. Okay. This is your n cap. Okay. So therefore the velocity vector will become the magnitude of velocity, which is given here as 65 meters per second, into that unit vector in that direction. So that is 65 into 3 I cap plus 4 j cap plus 12 k cap whole by 13 in meters per second, because the 65 is in meters per second. So now just do the maths. algebra. So the velocity vector is coming out to be how much? 15 I cap plus 20 j cap plus 60 k cap in meters per second. So now we've got the velocity. So from this, next thing that you have to do is you have to find the displacement in 2 seconds. So that displacement in 2 seconds will be nothing but the vector AC, and from that you will get the coordinates of the points. Okay. So just write down up to here and try to complete these steps yourself. Okay. Again, I'll explain, but it's important that you try to work this out yourself. But basically, this is an application of vectors in three-dimensional kinematics. Just try this out. Okay, so hope we would have completed this. Now you can see that here the displacement AC will become velocity into time. So 15 I cap plus 20 J cap plus 60 K cap into 2 seconds. This was in meters per second. So that is 30 I cap plus 40 J cap plus 120 K cap in meters. This is the displacement from A to C. So now you can see that if A is the point 1, 0, 0, then what should be C? So C should have an x coordinate of 1 plus 30, so that is 31, a y coordinate of 0 plus 40, so that is 40, and a z coordinate of 0 plus 120, so that should be 120. So these are the coordinates of C: 31, 40, 120. Okay, so that is question 13. Okay, people, so hope this is fully clear to all of you. So now next let us move on to question 16. I'll explain. See, what is happening is that if you are going from a point A to a point C, and that displacement is 30 I cap plus 40 J cap plus 120 K cap. Okay. Now A K coordinates, so this is the displacement. Okay. Now suppose A K coordinates x1, y1, z1 है, or C K coordinates x2, y2, z2 है. So what is that displacement? It is x1 minus x2. Sorry, x2 minus x1, because you're going from 1 to 2. So is this now? Got it now? So this x1 minus x2 is how much? It's 30. This is 40. And this was 1, 0, 0. So this we have to find out. That's what we are doing in that question. Okay, now let's come to 16. So three forces are acting at a point in a plane. Angle between P and Q is 150, Q and R is 120. Then for equilibrium, the ratio of these is how much? Okay. So equilibrium का मतलब क्या है? Equilibrium का मतलब net force should be 0. So here the equilibrium means that the vector sum of P plus Q plus R should be equal to 0. Okay. And it is given that P and Q are at 150 degrees and Q and R are at 120 degrees. So we have to find the ratio of P is to Q is to R. Okay. So this is pretty simple. You can just suppose we assume that the vector P is along our x-axis, or rather we assume our x-axis is taken along the vector P. So my vector P should be like this. So Q is at 150 degrees to this. So where is the vector Q lying in this now? The vector Q should be here. Such that this angle is 150. Now if you see the vector R, it should be at 120 degrees to Q. So it should be like this, at 120 below. So you see that this vector R will become like this. Because we want this angle to be 120. Now just write them in component form. So we can write P as some unknown magnitude into I cap. We can write Q as minus Q root 3 by 2 I cap plus Q by 2 J cap, and R as just minus R J cap. Okay. So now we want the resultant E plus Q plus R to be 0. That means P minus root 3 by 2 Q I cap plus Q by 2 plus Q by 2 minus R J cap should be a null vector. So that means P minus root 3 by 2 Q should be 0, and along with that Q by 2 minus R should be 0. Okay. So that means P should be equal to root 3 by 2 Q and Q should be equal to 2R. So P is to Q is to R will become and Q we can write as 2R. So this is the easiest way of solving this question. You can also understand this geometrically, that the vectors P, Q and R are forming a closed triangle like this. If their sum is 0, now this angle, the angle between P and Q is given to us as 150, which means this interior angle is 30, and the angle between Q and R is given to us as 120, which means this interior angle is 60, which means that this has to be 90. So you can see that E is to Q is nothing but base upon hypotenuse, so that's cos 30, so that's root 3 is to 2, and Q is to R is 1 is to sine 30. R is to Q is 1 is to 2. that's the same as this. This is the same as this. And this is the same as. So that's another way of doing this problem. Alright, so that completes question number 16. So moving on to 17 and 19 now. So 17 you can do very easily by just using geometrical method. So in question 17 is saying that you have two vectors u and v such that if we take the resultant of u and v as r, then this resultant has a magnitude which is half of the magnitude of u, and r is perpendicular to u. Okay, so just draw the vector triangle. So you'll understand that if let's say this is the vector u, then the vector v has to be such that its resultant with this u plus v is such that the resultant is perpendicular and of magnitude half of this. Okay. So what we have to do now, we have to find the angle between u and v. So we have to find out this angle. The angle between u and v is this one. Find out how much this angle is. Okay. So if this is x, this is x by 2. Oh, it's half the magnitude of v, so not my mistake. It's half the magnitude of v. It's perpendicular to u only, but so if this is x, let mod v is equal to x. Therefore, magnitude of the resultant is x by 2. So you can see that if this angle is some, let's say beta, okay, so you can see that sine beta is equal to half. Therefore, beta is equal to 30 degrees. So now, importantly, the angle theta is the one you are looking for, and that becomes 150. Okay, so the angle between u and v is not an acute angle. It's the exterior angle which is obtuse in this triangle. So that's the 17th question. And moving on to the last one in this exercise, 19. Okay, so hope this question is clear. So question 19 is just about inequality, okay, saying that if one force is, let's say, the vector E, which is of magnitude 6 newtons, another force B is of magnitude 8 newtons, then what we can say about the resultant? So triangle inequality mein resultant cannot exceed A plus B and cannot be less than the difference of A and B. So in this case, whatever the angle between A and B, in no circumstances it can be greater than 14, and in no circumstances it can be less than 2. Okay. So from this you can see the options. Okay. To produce the effect of a single force, that means a net force, can it be 1 Newton? The answer is no, because it can't be less than 2. Can it be 10 Newtons? The answer is yes, because 10 is between these two. Can it be 16 Newtons? The answer is again no, because it's greater than this. Okay. And can it be 0? Again no, because it has to be greater than 2. So it's just about triangle inequality, not nothing else. Okay. So this completes the doubts of exercise 1. In case you haven't worked out everything, make sure you do question 21. It's an important question to do with projections. Okay. And also you work out exercise 2 fully. That's again important to do with projections. Now we'll have to conclude today's session here. Some of you have asked me questions in exercise 4. I will help you out with them in the next turn, or in between, if you can try out those questions again. Maybe you can discuss with me. I'll give you some hints over WhatsApp if you can send me those questions. Okay. But next time we will complete the doubts of this and we'll start with Newton's laws of motion. So next chapter we will do will be Newton's laws of motion after completing the remaining doubts. Okay. So for this you will get a module which I will send to you, a PDF module. But in addition to that, we can also use some reference books. Okay. For physics, for iit-jee, can use part 1 and 2 by Dr. H.C. Verma. Okay. And we will also use the reference book, physics, part 1 and 2. Okay. So these two books will be using for doing numerical problems. in addition to the module. These only. It's part of this. Kinematics also from this only you study. And this one is for theory. For theory reading. And this is by Bharti Bhavan Publications. This is by Wiley Easton. And this is by Arihant. So you can find these books easily via e-delivery and all that. They are available on websites for e-delivery. But you get hold of these books, they will be useful. Similarly, for NEET also, we will be sending an official list. We'll also be sending an official list of reference books, which will be up on the website. For NEET, it's actually very similar. We'll be using iit-jee as well as Resnick Halliday for theory. Only the third one, instead of physics for JEE mains and advanced, the same publication, Arihant publication, has a series physics for NEET, or physics for medical entrance exam, by the same author, DC Pandey. Okay, but it's a different series. So these books you can use for all the chapters in physics, including kinematics, laws of motion, chapters of class 12 later, everything will be there in this. Okay. That is just, I wanted to give you some information about the reference books. Now that we've finished vectors, you can start getting into reference books also. Okay, that's it for today's class, people. I will send you the this thing. We call it the whiteboard notes. Okay, so you can go through this. Okay. So try to Cengage also you can do, but not necessary at this stage. Okay. Cengage you can do alternately to DC Pandey. Instead of DC Pandey, you can do Cengage.